Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Integrate the following with respect to x, and we've been given four functions. So the first function which is given to us is 1 by sine square x. So what do we mean by integrate with respect to x? We've been given dy by dx is equal to 1 by sine square x, and we've been asked to find what is y, right? So that is what we mean by integrate the following with respect to x, right? So what is my 1 by sine square x? My 1 by sine square x is nothing but cosecant square x, right? And this is where I want all you folks to remember all the identities that we learned under derivatives using first principles, right? So I know that from first principles my d by dx of cot x is minus cosecant square x, right? So then I can multiply on either side by minus, which means my d by dx of minus cot x is plus cosecant square x, right? So this is what we know from first principles. So this particular equation, we've been given dy by dx equals cosecant square x, and we've been asked to find y. And I know that we can have many antiderivatives for a particular function, right? So what we've been asked to find is the antiderivative. We've already been given the derivative, which is dy by dx, and it can have many antiderivatives. Why? Because if I add a constant, right, whose derivative is always zero, my RHS still remains cosecant square x no matter what the constant c is, right? Therefore, when my dy by dx equals cosecant square x, I will have to represent y as a function plus a constant c whose derivative is always zero, right? So when we rewrite this particular answer, I write it like this. What is my y now? My y is the function inside dy dx, right? So let me highlight it in yellow. It's nothing but a minus cot x plus c, right? That's how we go about solving these problems. And it's always useful to write it using the beautiful integrand symbol, and we've been asked to find integral of 1 by sine square x dx, right? This is how we write um, the integral equation, right? Just like how you have a dy by dx, your integration of a function with respect to x has been written like this, right? So that's the final answer for our problem 1. Let's go to problem 2. Tan x by cos x. Now, this is nothing but, and this is what I want you folks to familiarize with. My tan x by cos x is nothing but tan x into 1 by cos x is 1 by cos x is a secant x, and therefore I have a secant x tan x, right? So I should immediately be able to draw a parallel to what I learned under derivatives of first principles, right? I know that my d by dx of my d by dx of secant x is nothing but secant x tan x, right? Let me write it here. Now we've been given dy by dx equal to secant x tan x, and then they've asked us to figure out what is our y, which is nothing but our antiderivative, right? So I know that d by dx of secant x equal to secant x tan x, but at the same time, because of some rule in differentiation, and that I know that d by dx of a constant is zero, I can have many antiderivatives for secant x tan x, which are differentiated by this constant c. The idea behind this is, let's assume we have a function secant x plus phi, right? I know that the answer out there for derivative of secant x plus phi is secant x tan x, because d by dx of 5 equals 0. And instead of 5, I can also have a 7, right? And instead of 7, I can also have 100, right? So likewise, for c, can take multiple constants, right? So for the same derivative, you can have multiple antiderivatives, right? Now let's go to the next line, and more or less we have solved our problem. So let me write down what is my y using the integral symbol. I've been asked to find tan x by cos x antiderivative, which I represent by integral of tan x by cos x dx, which is nothing but secant x tan x dx, which is nothing but, I go back to what I wrote just now, secant x plus c, right? So that will be my answer for this particular problem. Let me highlight it in pink before we move to the next problem. My next problem is cos x by sine square x, right? Again, looks like we have something very familiar to us. My cos x by sine square x, I write it down. My cos x by sine square x is nothing but my cos x by sine x into 1 by cos x, right? So I can write it as cot x cosecant x. Right? And again, I want you folks to draw a parallel to what we learned in first principles. What we learned in first principles, my dy by dx, I've been given as cot x cosecant x. I've been asked to find y, right? I know from first principles that my d by dx of cosecant x is minus cosecant x cot x, right? So let's write that. D by dx of cosecant x is nothing but minus cosecant x cot x. Cot x, right? And go to the next line. Now I've been asked to find y. So if my d by dx of cosecant x is minus cosecant x cot x, then my d by dx of minus cosecant x is nothing but plus cosecant x cot x, right? And like I told you earlier, we can have many antiderivatives for a single derivative function. Why is that? Because I know that my d by dx of constant is always 0, right? So my d by dx of minus cosecant x, while that is equal to cosecant x cot x, my d by dx of minus cosecant x plus any constant c will also be equal to cosecant x cot x, right? So now let's go to the next line. Write down our y equals integral of cos x by sine square x dx, which is nothing but cot x into cosecant x dx. I go to this function what we just now worked out, d by dx of minus cosecant x plus c equals cosecant x cot x, which means the antiderivative of cot x cosecant x is nothing but minus of cosecant x plus c. And then as a quick check, let me highlight the final answer in pink before that. As a quick check, you can differentiate on either side, dy by dx equals minus of d by dx of cosecant x. And what is d by dx of cosecant x? It is minus cosecant x cot x, right? So minus into minus becomes plus. My d by dx of the constant is 0, and I get back my cosecant x cot x, which is my cos x by sine square x, right? So that's how we go about doing a quick check on all these problems. Let's come to the final problem in this particular section. So what is it that we've been given? 1 by cos square x, right? 1 by cos square x is nothing but a secant square x. And when I say secant square x, you should be able to immediately recollect that my d by dx of tan x is nothing but tan x is nothing but secant square x, right? And therefore, what is my y now? Y, which is the antiderivative of the given function, 1 by cos square x dx equals secant square x dx. Remember that we have the integral sign here, and my apologies, looks like I missed it in the previous problem. Let me add it out here, right? So secant square x dx, and therefore my antiderivative would be tan x plus c, right? And why is c coming into the picture? Because dy dx of a constant is 0, and for the same derivative I can have many antiderivatives, right? And all those antiderivatives are differentiated by the constant c. So let me highlight it in pink. So there we have. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.